Hi everyone. Fractions are a great way of describing parts of collections and parts of wholes, but we should learn how to do it before we actually work out what the calculation is, or at least determine what it is we're trying to do. So we'll start with a whole. A whole is typically something that's the whole thing. So a whole apple, 2 whole apples, 10 whole apples, or a whole meter, or 10 whole meters, or 100 whole meters, or 1 group of birds, or 5 groups of birds. There's no parts involved. And if we use natural language, describing a part can be quite imprecise. So we might have an apple and a bit more of an apple, or most of a meter, or a group of birds split into smaller groups. So if we had 3 groups of birds here and we wanted to split them into a smaller group, we might have 1 group of birds and 2 other groups of birds. Yeah. What we want is some more precise language, so we can describe what it is that we're trying to achieve, better than just a bit more, or most. So fractions are a great way of doing that, because as we know, it takes the number of parts that we have and splits it into the number of parts we need. And we can do that with length. So if we had 4 meters and we split it into 4 parts, one of those parts would be 1 meter long. And the way we'd say that with fractions is, if we split 4 meters into a quarter, into quarters, so that we had 4 parts and we're selecting 1 part, 4 parts and we're selecting 1 part, the answer for that would be, there'd be 1 meter in each part. So if we had a quarter of 4 meters, each part would have 1 meter in it. Now similarly, if we had 3 parts, after splitting 4 meters into 4 parts, how many would we have? So here we have 3 parts out of 4 of a 4 meter length. There'd be 3 meters total. 1 meter, 1 meter, 1 meter, 3 meters altogether. Now we don't know how to make this into a calculation yet. We can just see logically that that's correct. So we found some way of saying, if I want this bit, how much is in it? So this bit is 3/4 of the whole thing. And if we work it out, 1 meter, 1 meter, 1 meter, we can find out that that part is actually 3 meters long. We can also do it with area. So here we have a rectangle, and we've said the area of it is 20 meters squared. And we've split it into 4 parts. So 1 part out of the 4, 1 part out of the 4 of the entire 20 meter square is 5 square meters. 3 parts out of the 4, so 1 part, 1 part, 1 part is 3 parts, of the 20 square meters of the whole would be 15 square meters, because we just add up the areas. We could do it with parts of a collection. So we've got a collection of 16 circles, and we split it into 2 equal groups. There you go. It's 1 group here, 1 group here. 1 group out of the 2 groups of the total 16 circles would be 1, 2, 3, 4, 5, 6, 7, 8, because that's the amount in one of the groups. So if I look at 1 group out of 2 of my whole 16 circles, I would have 8 circles. If I looked at the whole of both groups, 1 group, 1 group, 2 groups, out of a collection that's split into 2 groups with a total of 16 marbles, it would be all 16 circles, because I'm counting both groups. That's what this 2 at the top here indicates. We can also do it with quantities. So in this case, we've had units, we've had groups. Here we have quantities. We've got the number 16, and we want to split it into 4 parts. We're not saying it's units. We're not saying it's people, circles, meters. It's just the number 16. It's just a quantity. So if I split 16 into 4 parts, there's going to be 4 in each part. 4, 8, 12, 16. Yep, that adds up correctly. Now if I want 3 of those 4 parts, 1, 2, 3, so 3 out of 4 parts of 16, we know it's going to be 1, 2, 3, 12, because that's how much is in each part. Yeah, so there you go. I hope that's helpful, and we'll go on to the next idea. Thank you, everyone.